Welcome back. This is our second part on weighted queries. In this section, we'll learn how to get extra information about the query results obtained in our last session. Remember, for this demo, we're using a database containing information about movies. We can see the structure of this database on the left. We have a container of movies that has documents of type movie and a container of persons with documents of type person. A movie document has the following properties: name of type string, date published, of type date, and actors, authors, and director, which these last three are arrays of relationships to documents of type person. We can see the query we worked on the previous session. This query is intended to get results on a search looking for movies with dark and night on their title. We executed and we get results on the number of the white criteria that meet the search terms, having the higher place those titles that better match said terms. Now we're doing a more complex search. We are searching for those documents where some of the people involved in the movie have the name that we are searching. This means that we are searching for movies by their actors, authors, and/or directors. To achieve this, we are altering our relationships. Since we are searching the movie title where a given name of an actor appears, we get the name of an actor and store it in the person variable and still get the date of publication of the movie. Next, we want to get actors, authors, and directors, so we are changing this relation to a variable that we will filter to make sure the relationship is only part of those mentioned before. In this manner, we get those results where people have the words dark or night in their name, and the relation between the movie and this person, whether it is an actor, author, or director. Even though this query seems to work, it has a problem. To show this, we will search for people that have the name Cohen. Once we execute this query, we see that we get results. Still, there's something particular. Some of the results appear to be duplicated, but that's because some people have more than one role in the movie, such as Ethan Cohen and Joel Cohen, where they were both authors and directors of the movie. To avoid this repetition, we can add the group by clause. We now group by movies, and for some information, we can add weight and date published. Since we are using the group by clause, we should have to be more specific by selecting the variable by which we grouped our data. This gives more precise results on what we're looking for. We can see now that movies are not duplicated in our results, but we lost some of the data, such as the relation between the person and the movie and the name of the person. And our next step, then, must be to see how we can get further information from our results. As we are using the group by clause, we can use a SPARQL function called group concat, which allows us to add information to our results. We can do a group concat of the name of the person involved in the movie. This way, when we execute the query, we get the previous results as well as the name of the person involved in the movie. Group concat also allows us to separate the values with the character that we provide. In this case, we're using a dash to separate these values. As we execute this, we can now see our values separated by a bar giving more clarity on the results. We can also do this with our relations to see what they do in the movie and the ID that this person has. Now we get more information on this query, and results are ordered in the same way that the name column. Let's see now this in our live example by using the same search service than our previous session. We already have Carbon LDP instantiated in a variable called Carbon LDP. Now, we have a new method named search with extra info that has the same parameters as the last one. This query is now dynamic, and keep in mind that we can get the prefixes from a previously made function to reduce work on typing each one of them. Now, every section that has static code is replaced with dynamic code. In this case, we're using template strings to do so. In the end, we must execute our query with execute select query and assign it to query results. So further on, we can get those results we want through the bindings function. Since this query gets more sophisticated results, we have to change this a little. In this case, our function will not only retrieve an array of movies, but an array of movie search results. This is an interface that was previously made. Let's take a look. This interface is just one element of our search results that contain movie-related documents, an array of strings relations, an array of string as well, such as an actor, author, or director, and finally, matching values, in this case, the name of the people involved. Take into account that, since we are using group concat, our results will come back as a string, not as documents, so we have to be careful with that. When we go back, we also have to adapt our code to get those results. We now see that instead of movie results, we get search results, and to have some type validation, we'll say that our variable is an array of type movie search results. Now we're changing the function used to get the movie and instead use a complete function. We are assigning some of the values of our search to our array of movie search result. We're storing each value in the corresponding result. In the case of related documents, we have to split the result by a given character, in this case, our bar. We will reuse this for relations and matching values as well. In this way, we are now storing our results in an array of objects, which give more information on what made them match our search. On the other hand, we're still missing how to retrieve detailed information with our personalized function for movies. To do this, we'll use the array of objects made and make a map on the movie property. We no longer need to assign this to a variable, but we'll be making use of the shared cache Carbon has, so the movies will update in the background. Finally, we are returning our movie search results. With these results, we now provide our interface all the search information, and once this function connects to your user interface, we can see the following. When we search for Will, we get all those movies where a person with the name Will appears or is involved in. We can do this as specific as we want it to be. If we go back to our example, Cohen, we get Joel Cohen, Ethan Cohen. If we search only for Joel Cohen, we get specific movies where Joel Cohen was involved. In this way, we can give more accurate information to our users. Weighted queries are a commonly used tool to make search more accurate to our users' needs. With linked data, relations are as important as the nodes they connect, and weighted queries allow us to see this.
And hit subscribe to get our updates.